talking about angular measure. This idea we have something called degrees, of which there are 360 degrees in a circle. And this other measure, which is radian measure, of which there are 2 pi radians in a circle. It's not useful to know that 1 degree is approximately 0.01745 radians. It might be a little useful to know that 1 radian is about 57.296 degrees, almost 60 degrees for a radian. Think about it. Triangle has pi radians. Some of the angles is pi radians, which is about 3. If you divide it by thirds, it's about 60. We do need to be able to convert between them. So to go from degrees to radians, we can divide by a radian measure that's equal to a divided by a radian measure. So if I say 53 degrees, I'm going to multiply that by 2 pi over 360. Once you get used to that, you realize there's an extra 2 in there I don't need. So you multiply 53 degrees times pi over 180. Save you a few buttons on your calculator. Similarly, if I had, say, pi over 4 radians, and I want to go to degrees, so I can multiply it by 180 over pi. That all works nicely. I plus out pi, divide 4 into 80, and I get what? 45 degrees. So you need to be able to, you need to know the conversion factors. You need to be able to go back and forth. There's also, I think we mentioned already, a certain number of angles that you really shouldn't, I would say, commit to memory, but I don't think it's memory exactly. It's something else. See, degrees. Some kind of familiarity. So, 360 is 2 pi, and 180 is pi. 90 degrees, a familiar angle, a right angle, right? What we can see here is just going to be pi over 2. I'm going to do this out of order, but if I divide this by 3, I'll get 30 degrees, or pi over 6. And then 60-degree angles are somewhat ubiquitous. This times 2, or pi over 3. And then finally, we might divide 90 degrees in half. 45-degree angle would be pi over 4. And if you know all those, anything else that comes up, you can do a conversion. It's just that we, when we're doing trig functions, we may go back and forth between radians and degrees. And if we're using a somewhat standard-looking angle like one of these, you want to be able to recognize it, know what it is. So, last thing I'm going to remind you, this feature of radian measure, which is if you have an angle in radian measure, and you know the radius of your circle, you know the length of the arc it subtends. It's just r theta is going to equal s. When r is conveniently 1, which we're going to do a lot, we're going to have a unit circle, then the radian measure is equivalent, it's equal to the arc length. And just as one minor example, if you think about 2 pi radians, well, that's going to be the circumference of a circle with radius 1. All right, now we're going to do something a little different, just a little different from what we've done with angles in the past. Up till now, when you thought of an angle, you might have thought of like an angle in a triangle or a polygon. In a triangle, you could get, most of your angles are less than 90 degrees, right? Most of them. But you could have a triangle with an angle greater than 90 degrees. Anyone remember the name we give to that kind of angle?
What? Obtuse?
Obtuse, yeah. This is an obtuse angle because it's greater than 90. All these other angles, they're small and cute, right? So they're a cute angle, right? It's a bad geometry joke, all right. But what we're going to do is we're going to, oh, and maybe you've heard of straight angle, right? Straight angle doesn't look like an angle at all. It's just, you've got 2 rays, point in the middle is their vertex. It kind of looks like a line, but that's a straight angle, 180 degrees or pi radians. So now we're going to kind of put angles into a framework. We'll start with our XY axis. And we're going to call this an angle in standard position. And one of the rays is always going to be along the x-axis. The second ray will be somewhere, right? And our angle, we're gonna actually give our angle a direction. It's going to be counterclockwise. So for a typical angle we deal with, like this, let's say this is a 60-degree angle, or it's pi over 3. We've got our starting ray, and we call this it's not important name. We call it a terminal ray. But we're no longer limited now to angles less than 180. We could have an angle that goes out this way. This is between 90 and 180. But we could keep going. Right? So now I have an angle here. This is 45 degrees, 180. So this is this angle here is now 225 degrees, or pi plus pi over 4, 5 pi over 4. In addition, since we've designated counterclockwise as the positive direction for an angle, we can also have angles with a negative value. So for example, I might have an angle like this. This could be minus 45 degrees. Anyone not run into this before? I'm just curious. So you've all kind of seen this kind of angular measurement, negative angles. All right. One thing we have now that seems a little odd is we could have an angle that starts here, goes around, maybe terminates, maybe goes around again. So this angle would be, this is 45 degrees, but I've gone around 360 twice, so 720 plus 45 is 765 degrees. Now, that might seem a little absurd, but consider a problem where, say you have a spool of, I don't know, cable. Like maybe there's an anchor, maybe there's a boat anchor. Kind of smiling there. And you want to pull it up. Well, you might want to turn this spool through more than 360 degrees. So this does have a use. This also has the feature that positive and negative angles mean something, right? Positive angle is pulling the anchor up. Negative angle, we rotate it through a negative angle, lowering the anchor. However, we have to recognize that if we just look at this and we see this ray and this ray, we don't really know, is this a 45-degree angle or a 765-degree angle? Well, we might know, we might say it is, but we have a way of relating these two angles. We would say that these are coterminal. Co meaning the same here, meaning they terminate at the same ray. For some purposes, we're going to say those angles are equal. So if I have like a pointer on here and I have a scale around my spool, even though it might rotate through some large number of rotations, where it ends up on the scale, it's limited to 360 degrees or 2 pi. So we might want to indicate that two angles are the same. We could say angle A might be equal to some other angle plus either 360 degrees times some integer, or if we're using radians, we would say plus 2 pi n. N takes care of positive and negative. So these are equivalent coterminal angles. And I think that's it. That's angle measurement. Any questions? Okay. Since, no offense, no one turned in any homework, there was a homework assignment. I'm just gonna, it was a small one, I'm just gonna add the assignment for today onto there and check. Don't check, you know, for at least 12 hours. I'll probably move the due date forward some number of days. Thank you.